Yes, probably, yeah. That's why I suggest you just don't spend. So we just, because as I suggested, we just go through that old paper, right? In order to know what are the required scope and the depth, right? Or
Yeah.
challenging level.
I think that's the
Well,
best way for me to like study for this, because otherwise I don't have any other method to do this.
yes.
Yeah.
So let's go to this first paper. Well, we still not have time on this first paper.
Yeah.
Well, at least we can, perhaps today we can finish this one. I hope. So look, if we know how to solve the problem, then we just we skip that, all right?
Okay.
And we don't, and also we don't have to deal with numerical at this stage, right? So that we can move forward faster, and then we can always go back, right?
Yeah.
To look at it again. If anything unclear, let's go to the where done that trigonometry. That's something new. Oh, we got this first like, this we have done this.
Yeah.
Yeah, total volume. Yes, we have done that. This one. Yeah, this new planet. We have done that, all right?
Yeah.
Size of that's good. We have made some progress. How about this one? Aha. We have done this as well, do we?
Yeah.
It's just algebra, right? It's algebra. Continuous condition. So it's not a big deal. Page attention working. Aha, this is one called bending, right? Bending. So the phenomena itself is abstract, but doesn't matter. They just tell you that there's a formula. Can you see? There is a formula for the angle, which is we have to consider whether the formula is correct. Can you see? So this is a formula we need to consider. And among them, the c is light speed, right? We can recognize, and g is gravitational constant. Can you see?
Yes.
Mass is passing star. They got a passing star. So basically, the light passing a star of mass. So this is a mass star, such as the sun. Okay, such as the sun. So basically, the even using Newton's law, you can imagine the particle will be attracted by this heavy star, so that they will change the direction slightly. That's called bending. Okay, but in this case, we are dealing with light. We say that is light basically light is a wave, right? It has no mass. So that is very interesting. That is a very challenging question. Actually, Einstein's theory, general relativity, is based on this observation. So forget about the background. We just focus on whether this formula is correct, right? The lambda is undetermined dimensionless. So when you see this is a keyword, do you know that this means no dimension, all right?
Yes.
In other words, just constant, just number, okay? Just number. So we don't, when we consider whether this formula is correct, we don't have to consider lambda, right? And by considering the dimension of this equation, determine these three numbers, alpha index, can you see? Alpha, beta, gamma, okay? Do you remember the notation we used? So we did this question. We first use this notation. Can you see? There's a square bracket just indicate that we are looking for the unit of this quantity. And because lambda is just constant, so we don't have to consider lambda, right?
Yeah.
So we just go to the gravitational constant. And this is just like product factors. Now here we got the mass to the power alpha. Can you see?
Yeah.
And then we got to the r, the distance, to the power of beta. And finally, we got to the light speed. Can you see? The light speed. So that is a c. We can put the power outside as well. Can you see? It's got put the gamma here. Can you see? That is step one. We just dealing with this, we don't have to consider the dimensionless constant, okay? Now, here we have used our knowledge to work out this, do you have the table for gravitational constant? What is the unit for that? If you don't, we can work out this by this formula. Can you see? This is can write down here. So the related formula, so write down here. The related formula for gravitational constants, Newton's law. Okay? To find the right unit, we just consider the two mass are identical. So that's r squared. So therefore, G should be equal to, we solve the G, that is F multiply R squared divided by M squared. Can you see that?
Yeah.
So if you that's what's unit. So unit must be the force is a Newton, all right?
Newton.
That's meter squared. And meter cancelled. Can you see? The meter squared cancelled?
No, it doesn't. Meter squared per kilogram squared.
Oh, hang on, probably something wrong. So this multiply R squared divided by M squared. Oh, it's different. Meter squared is kilogram.
Kilogram,
squared.
yeah,
Okay,
kilogram squared, yeah.
Okay. And at the moment, it's not the basic unit yet, right? The basic unit for what is Newton? By the way, Newton can be written if you according to another formula. Okay, this is the first formula.
MA.
Yeah, F equal to MA. That's right. So can we just simplify this? I just show you. The second formula is F equal to MA, right? Equal to MA in order to find the unit of Newton. So this is the unit of force. What happened to my pen? That is we know that is a kilogram, you see? Meter S -2, right?
Yes.
So that is Newton. So that is a Newton. That is a Newton. So if we substitute that one, so therefore we can work out the unit for the gravitational constant. Can you see? So that is F for F Newton is a kilogram, and M meter is meter square or meter is meter. No. Oh, this is a what minute? Mass is a kilogram. Sorry, sorry. Oh, we have used.
Yeah, it's
what?
M kilograms for M.
Oh, meter. This is meter. Yeah, should be meter. Yeah, should be meter. Oh, I get confused. Okay.
Meters cube.
And yeah, meters cube now, right? Can you see? And divided. I have to put the S to -2 here, right?
Yeah.
That's Newton. Is that right now?
Yeah, and over kilogram squared.
Over kilogram square. So we can cancel 1 kilogram. Can you see?
Yes.
So that is how to achieve that. Okay. And this cancel that one. So that's G. Okay. So this, once we got the G, we can write it here. So another, can we just consider that we can put the can we use you know, be crowded here. Let's just use some one moment. I use hold this space. So what can we do? Oh, yeah. Can we rewrite this formula over here? So the theta has no value, no unit. Can you see? Because theta is angle. Angles it doesn't count. The angle doesn't count. All right.
Okay.
So therefore, we don't have. So therefore, this actually in term of the in term of the basic unit, that should be kilogram to the power of 0. All right. And then that is meters to the power 0. Okay, and the second to the power 0. You see that? Because that is a theta, all right? That is a unit for theta, which have no dimension. Okay.
Three the basic.
That's basic unit in mechanics. If you want to, if that includes the electricity, you have to consider amp and coulomb. Okay. And if you study thermal, you have to include the Kelvin. But this is a mechanics, so that is enough. Okay. Yeah. So that is the left hand side, all right. On the other, so that is so this is theta. On the other hand, and this can you see this is the left hand side? Okay, right this way. So left hand side is equal to this, all right. How about right hand side? Right hand side, we got a G now. Can you see this is our G? Okay. Don't double check that. So that's a meter Q, right? Is a meter Q degree. And S is -2. Can you see that? And the kilogram, -1. Can you see? Kilogram, -1. That is our G. Can you follow me?
Yes.
And then we go to M. M is just a kilogram. Can you see? That would be kilogram to the power of alpha. Do you agree?
Mm-hmm.
And that R is distance. That would be the meter to the power beta. You know that?
Yeah.
How about C? C is a meter over second, right?
Yes.
So that should be equal to meter gamma multiply second negative, right? Negative gamma.
Gamma,
right?
yeah. Mm-hmm.
So they just index. You can use index node now. Can you see?
Yeah.
Can we put a kilogram first? Can you see? How many? So -1. So that is -1. Can you see? Plus gamma. That's
Plus
it. Okay.
Alpha. Yeah.
From alpha plus alpha.
Mhm.
Okay. How about the meter? Meter is 3. Can you see? 3
Yeah.
multiply beta
Beta.
and plus
Gamma.
gamma.
Yeah.
Okay. But finally, what is second? Second, we got a -2, right?
Yeah.
And
Ne-
minus gamma.
Yeah.
So you know how to do that? Do it now. You got 3 equations. Can you see that?
Mm-hmm.
So by comparison, so from this equation, we can got that 1 is that alpha -1 equal to 0.
Yes.
Okay. The second is beta plus gamma plus 3 equal to 0. You see?
Yeah.
The third one is 2. You can use plus, doesn't matter. So this equal so -2 negative gamma equal to 0. You see?
Yeah.
Okay, I will stop here. You can solve everything. Can you see alpha will equal to 1? Can you see?
Mm-hmm.
It's just simple simultaneous question. I'll stop here, right?
Yeah.
Do you know how to solve this type of question now?
Yeah.
You just compare the power, the index of basic unit. Okay. So the international system, in the international system, they are the basic unit. So any quantity in mechanics can be represented by the power of these 3. Can you see? One is the length, another is the time, and another is third one is mass. Okay. So the length is a meter, international system. Time is second, mass is kilogram.
Oh.
Okay, is that simple? Yeah.
Yeah.
So this is a type of question. So when you encounter again, you can always check this question. All right. So I'll save that, and then let's go to next one. One moment. I've cleared that. Oh, haven't finished. You have another question, but before we go, I have to here shift that. This is question B. Oh, what is A? What is question B? Can we look at question B? Oh, they got this constant. So in these are international systems, and the gravitational constant is given, right?
Yeah.
And neglecting any partial extended star explains the spatial extent of the star. So forget about the size of the star, basically. The size is relatively small. Taking lambda equal to 1, m equal to this one, determine the distance r that the light band is so much that it falls the velocity into the star.
Falls directly.
Oh, so you have to, so in that case, what is the angle? So basically, if
90 degrees.
90 degrees, yes, that's right. They have to burn 90 degrees. So if you know there's a condition, you should be able to solve this question, all right? You just use the formula we just obtained. Do you agree?
Yes.
We got the formula that, so we don't have to continue now. So if so basically this condition is that theta, if you can identify this condition or half pi, then you should be able to solve this question, all right?
Okay, should it be like in radian instead of degrees?
Yeah, because none of them has the unit, right? Radian doesn't count, so radian just number, and so degree is not the basic unit. Okay. We don't, degree is not unit in physics. It's just a unit for convenience. So we stop here, all right?
Okay.
If you have more time, we can revisit, okay? If you want to see more, we can go to next question now. Aha, this is geometry, right? So how do you solve this type of question?
Area of the dark regions.
Of dark areas, can you see? Before you go, what is the relation between the circle and this dark area? Can these two circles are identical? Do you agree?
Yes.
Can these small chemicals A1 is A2? Can you see these are identical? And so the big circle, can you see the total circle chemicals A? So A is equal to the sum. Oh no, the difference. Can you see?
Yeah.
So the dark area, can you see? Put the for the area for the dark, right?
Yeah.
We're equal to the total area. Take this two small one, can you see? And the two larger one. That is the formula.
Yeah.
Do you want to go further or shall we stop here?
What is the radius of A1?
A1, well, you have this geometry. You see? Can we draw the? Can we? Yeah. Do you want to try or not? You can draw a triangle here. Can you see? This one, and this also the so can you draw a triangle? That will give you some clue. Can you see? Oh, this is symmetrical as well. Can you see? This is symmetrical as well. So you can consider this is a equilateral triangle. You see that? So it's just, you want to try or you want to, we just move to next question? You want to try? If you want to try, you can try. Can we call this R1? You can try. It's R1, R2.
Yeah.
Okay.
Like,
can you figure out the two radius? Because the A1 is equal to pi R1 square. Can you see? Oh, it's a circle. Yeah, do you want to try?
On it.
You can and you can choose the view option.
It was there, but it didn't come out.
Sometimes, yeah, you want to touch that once. Yeah, you will draw. You will if you use the mouse to touch the up edge.
I don't know. It used to be there.
Yeah, yeah. Did you install the Zoom or you just use online Zoom?
Sorry.
Yeah, that's right. Some function
last time.
Yeah. You did that time, yeah. Try it. You just move your mouse to the cursor to the up edge, and then the menu will drop. Ask you the view option. Can you see the view option?
Can I quit the room and join again?
Yeah, sure, no problem. I'll stop sharing. Yeah, you can.
Okay.
Okay, try again.
Mm-hmm.
Let's go to the, yeah, can you try to?
Yeah, I found it.
Good, good.
Yeah.
Okay. Okay.
So,
okay, can we, you can draw the triangle. Remember, I draw the triangle. Include, yeah, that's right. Include two radius. I think this is sufficient now.
is this length helpful to me? Because I can find this length, but I don't know what to use it for.
The length, yeah, you can use you can express that length. Can we use the letter? You can use this length to represent that. But do we need that? Can we, because this is a, can we use a small letter?
I just think I can I can't find it, but I don't know.
Can you put x, y is y, x, sorry, x, y, x, y, z?
Mm.
Do we need this? Do we need this side?
Not really. We need to find the radius.
Yeah, we need to find 2r
circle.
radius. Yes, how can we find that? The right angle triangle, right? Yeah, we should be able to find this side. Yeah, whether that side is useful.
No.
But they give us a relation, right? That's interesting. So how can we build two equations to find the we know the r, can you see? We know one r in terms of r is given. So this is given, only one unknown, can you see?
Yes.
So this is r. Yeah, can we call this small r? We only need to find a small r, can you see? So one equation would be enough.
Is there any relation?
Yes, we should be able to solve that. Can we find this height then? Use trigonometry.
It's this is r over. I can write.
Yeah.
R over 2.
This is r. Yeah. This is still r. Capital
No,
R.
it's r over 2.
Really?
Yeah, because that's the diameter.
Oh, that is diameter. Oh, okay,
Yeah.
this is half. This is half. You are right. This is half.
Yeah. So that length is. Wait, I can't. Can I? Oh yeah, I can.
I think Pythagoras will help you. Yeah.
R square equals. What do I call that length? L square.
Can we use L? Yeah, L. You code L. Yeah, code L. Yeah.
Does that help though?
Certainly the R, you can solve the R from we still have one unknown. L, how do we represent L?
L equals R plus something, but
yes,
no.
this is how can we work out L in terms of we don't know the angle, right? Yes, that's not enough. We need to find one more equation. So this is a Pythagoras theorem. It's not the right triangle. We know this side is R, right? The total size is R.
Yeah.
Is R. Well, this is how can any other geometry theorem is helpful. This distance. Yeah. Another thing, if you go further, can we make this extended? Can we build another triangle here? I think that probably will help you. See, that is I think there's some circle theorem. Do you know circle theorem? Yeah, can you draw another triangle here? Can you see that?
Yes.
So this angle must be 90 degrees. Do you remember this theorem?
Oh.
Do you agree? This must be right angle. That any line connect with the diameter, this angle must be always 90 degrees. Does that help? So I just draw it here. So that is there is can you see if this is diameter, right? If you choose any position here in the circle, then you will see that will be 90 degrees. Can you see? 90 degrees. So can we use this? Can we use this to obtain the? Yes, we should. We should. I know. I can see the possibility now. Can you see?
No.
Because this is a 45 degree. So this distance. So this is 45 degree. Do you agree?
Yes.
If this is 45 degree and these sides are isosceles, can you see? Can we go to A, B? Can you see A, B? This is a C, okay? So A, B, AC must equal to BC.
Yes.
Okay, what is BC? BC equal to the H, the L plus the small r.
Right. My God. So
Yeah.
AC is
Yes.
AC is R. Oh,
The AC is R2. Yes, that's right. AC is R2, capital R. You're good at math, right? I notice.
yeah. So you're supposed to.
Yeah, well, we got enough equation. Do you agree? We can find the small r in terms of capital R now, right? Can we solve, if you want to go further, can we solve this equation if you wish? We can solve the R formula for R. It's quadratic, right? It's quadratic.
Yeah, I expanded it.
Oh, the square term is cancelled. It's good.
Mm-hmm.
So 2R and R. Yeah, it's just algebra. Yes, I think. Can I help you to cancel this too? You see?
Oh, but there's R in this term.
Yeah, it doesn't matter. That can be combined with this negative 2R, right? Oh yes, you have returned. Did you multiply 4 or?
No, this is wrong.
You can. Oh, when you go back, it should be positive. Do you agree?
Mm-hmm. Sorry.
When you put this on
right.
negative. Yeah.
Right.
Oh, it's much simplified now. Yes. Oh, that's just 2 now. Can you just 2? Yes,
Yeah.
good. Yeah.
Yeah, and you just put that on the right
Yeah.
side. Get R.
Yeah. We can stop here. It's just a simple algebra. Simple algebra. Okay. So
Yes.
finally, what you do is just use this formula here, the built in the first place. Oh, I did delete that. Can we just write down here? So basically, the area for the dark, right, is equal to the total area. Take these 2 circle, okay, and 4 circle, different radius. You see, just use this formula. So stop here. All right. Yeah, it's very straightforward now. Okay, let's go to next one. Okay. So what's this question? Constant form the pile. You know the pile, just you drop the sand that will form, that can form a cone. Yes, a cone should be the cone. So you can draw the diagram to illustrate the question. What they're after, they found the, yeah, this is
I think we just tested on that.
Really in your math? Yeah, that's good.
A specialist math.
Oh, math C. Okay.
Exact same question, I think.
Okay. In that case, we.
Find dr dt.
The rate. Yeah.
When.
Yeah. Initial condition.
But it doesn't ask for the RDT at a certain time, but just the RDT.
They just look at it. I haven't read that in detail. So you got a time-dependent R, right?
Mm-hmm.
One moment. Just participate this. So can we draw a diagram here? So basically we got a time-dependent R, right? R is dependent. R at the beginning is 0, right? Presumably is R is 0 at the T0. And what happened to the T1? And with the T, if you take a T1 for the R to reach R1, okay, there's a condition, can you see?
That's for question B though.
Oh yeah, I just see the whole picture. T1 and R1. I just see what's going on here.
Okay.
How long does it take for the radius reach to R doubled? Can you see? I just I look at it as a, can we just say it's a problem like this? You see, it's not necessarily linear. It could be quadratic like this. All right, just see the question. So return to the first question. If R is the radius of the base of cone, so that is a base with R, right?
Yeah.
So both in the built up height as well, right?
Yeah.
And with time t given, how to find the varies? Oh, you need to find this function first. How can we do that? If this is height.
Do you need the volume?
Yeah, because after all the constant this is constant rate onto, so therefore you can imagine this is a source of the constant flow of R. Can you see? So that is a constant. So how do we describe that? Is a mass. That is a mass per unit of time, right? That's equal to constant, right? Of course, mass is equal to the the volume divided by density. So we can consider the density is constant, right? Do you agree?
Yes.
And so we have to work out the because of this volume contains the R. Do you agree?
Yeah.
How can we work out this R?
Volume
volume of this is just 1/3 of the column, right? Pi R square h. Okay. Now the question is, how do we find the h as a function of R or a time? We have used this condition. So the constant rate, how can we incorporate this rate here?
It's 0? Or like
no, it's constant. It's constant. It cannot be 0. It's constant. Can we use capital R?
Just a number.
Yeah, just the rate. So this rate is time dependent. All right. So that rate, as I defined here, can you see? If the rate is a total complement mass, and because in this is R is change, H is change. Can we find the, it's not straightforward. How can we find the dependence between H and R if this is a pile in the shape of cone? You can use a cone, yes, with constant slope. The slope is constant. Can you see
so
alpha is constant? So there's a simple relation between them two, right? So basically, so the tan alpha, can you see? The tan alpha, this is another condition, is equal to H over R. Can you see?
Yes.
So in that case, we can find this H. Can we write down here? So basically, can we just solve this one? So so the volume can be written as half 1/3 pi, and we just introduce this idea. This is H. H is R tan alpha. Can you see? And then that be RQ. Does that make sense? And we put a constant together. That would be pi tan alpha. Okay, pi tan alpha, and divided by 3. That would be RQ. Can you see?
Yeah.
Now, if we just, how do we incorporate this R? R, can we consider R is equal to dm dt, all right? And use our formula, if the density is constant, then that will equal to dv dt, all right? Can you see that?
Yeah.
So dv dt is a function of R, yeah, do you agree? This is equal to R, that do you mean this is R, can you see? So how much mass is a drop per unit time?
When you do the equation, do you derive both sides?
Oh, you have other idea. You can follow yours. Do you have
No,
other idea?
No, like this one. I'm saying this one. Did you derive both sides from this equation to get this one?
Yes, that is by definition, density is equal to mass divided by volume. Can you see? Do you agree? This is density, yeah.
I got it.
Because it didn't tell them, but we just assume it's a constant, okay? Because there's an initial condition, we can determine all constant, so don't worry, okay? Now, can we just find so this function of R, do you still agree?
Yeah.
So we can use a chain rule. Can we use a chain rule? So dv dt will equal to dv dr. Can you see? dr dt. Can you see this chain rule?
Yeah.
So dv dr can be solved. Can you see dv dr? What's the dv dr? Put this constant here. Pi tan. Excuse me. Alpha divided by 3. And see that's 3r squared. Can you see? And second is the dr dt. We just keep as dr dt. That's what I'm looking for. Can you see?
Yeah.
Yeah, that's what I'm looking for, dr dt. And now we can replace this by r. Can you see? Can we find the dr now? Can we put this as function of time? Where are we? We need to find r, how fast with the time. And oh yes. Can we just recreate this part? So basically, can we just substitute this one? Can we incorporate this r here? You see? So this dv is divided, so that equal to r divided by density. Can you see? Can you see? dv dt can be reverse r over density.
Yeah.
And that will equal to, this is also the constant. Can we just call this constant alpha? Can you see? Too many constant. Can we call it alpha or even put the 3 together? Can you see?
Yeah.
Can we call this all things alpha? Okay, that is r squared dr dt. Can you see?
Yeah.
See that? So that is function. Can you see that's time dependent function now?
Yeah.
So that is we can build can we multiply dt on both sides? First of all, we just first we can divide by alpha. Can you see alpha no? Can you see? And that multiply dt. So this part is just r squared dr. Can you see?
Yeah. Oh.
So we can do integration now. Do you agree? So we can integrate on both sides. Can you see?
The first one is just add a t.
Yeah, first one just can we call this a beta? Okay, I prefer to use a single letter to represent the things. This is beta t, all right?
Yeah.
And how about other side integration?
3
Q,
r
over
cube
3
over 3
Q,
plus
yeah.
d.
Okay.
Plus c.
Yeah, plus c plus a constant. Okay.
Yeah.
So we got everything. Do we got everything? Yeah.
Yeah.
So time is time dependent. Can you see? So in other words, the plus a constant. And can we make an argument from 0? Can we say from 0 to r? Can you see? If I use initial condition, this constant is 0. Can you see? I treat this as I treat this as a definite integral.
Yeah, that's true in this case.
Okay.
Yeah.
So in this case, we have used this condition. All right.
So C is equal to
That's
0.
right. So therefore we got this function. So therefore we got from here. You can try if you want to try. So that is 3 beta t. Can you see?
Yeah.
Equal to RQ.
Uh-huh.
So yeah, we solve that. Can you see what is RQ? That what is R? Sorry.
R equals
Root 3. Can you see?
3. Yeah.
Yeah. Beta t. 1/3. Can you see? So you agree?
Yeah.
So that's the first part of this equation. How about second part? Do you have any question about first part?
It's just so many constants.
Yes, but at the moment we still have trouble because we use this already. There are other constant. Can you see? The lobe is constant. Given if R is the radius of base cone, found that R varies with time. Doesn't matter. So you can explain what are the constant. All right. For example, density and what is the relation between density of. I just highlighted some basic relation. So important thing that this basic. Can you see the slope, and the volume of cone? Can you see? And so that's it. So that is how to incorporate. That is this is derived formula. Can you see? This is derived. So V is equal to this is derived. So important things that we got this formula. All right. That's very important. So beta is a constant. We have to. It's unknown, but the dependence is okay. Because when we studied the phenomena, we first found the dependence. Okay.
Yeah, it's just I've never do a question like this where you're like.
Yeah, no, yeah. Normally, we need to solve everything, right? In the textbook, we need to find the numbers as a solution. But I think this UK test is more concerned about analytical formula. All right. So in this case, for example, you can even draw the graph. Can you see? So the R is so this is R. Can you see? So this is small r. So it's probably just like this. T could do like this. Can you see? Yeah, that's right. Yeah. Well, that is the first part. How about the second part? Yeah, we can. Yeah, that is. Well, my diagram is correct, isn't it? This is my guessing. Do you remember? this is my guessing. Can you see?
And drawing.
Yeah, this is my first. You ask me why did you jump to the question 2? Because sometimes you need one. You don't have to follow the order. All right.
Okay.
Because the reason I did so, I just want to justify why there's a dependence. All right. So obviously this is very close. Can you see these two graphs are very close. So basically you just substitute this condition. We got T1. We got this condition here, right? Take T1. Then you can determine this unknown constant. Can you see? How long does it take to the radius to reach that one? So this time taken. This time taken. So how long does it take? That would be this time. Can you see? Oh, be careful. How long does it take? Is this one? Can you see? From here to here. They are looking for this time interval. Can you go to T2? So basically T is equal to T2 take T1. Can you see?
Yeah.
Because they ask after this, right? How long does it take for the radius to reach to R in terms of T1?
Do I need to make T the subject?
That's right. So we need to find the difference. So basically, from this condition, we can solve this unknown constant. All right. So in other words, do you want me to solve that? So R1, can we use this condition? R1 must equal to 3 beta. And I put RQ here, okay? RQ here. That will equal to T1. So beta is solved, can you see? The beta is solved, can you see? This unknown constant is equal to R13, okay? divided by 3, isn't it? And T1 and T1. Can you see? That is how to solve the beta unknown constant.
Okay.
Okay. So once we know that, we can use the same formula. So this we can use the same formula to say what is T2. Can you see? Once we got a T2, we found the difference. Then that will be the time taken.
Oh, you just used the.
We got 2 times. You see, I just highlighted this formula for you.
Okay.
So that is a simple relation. All right.
Yeah.
And that is how we build. That is how we build. That is how we solve the constant beta. Can you see? Beta is determined. Once you know the beta, then we can use this formula now. Can you see? So this is the formula between R and T.
And the.
Can you follow me? No.
But don't you like sub in T to R1 and T2, and then
I use this corner to explain to you.
Subtract them.
Yeah, I use this across. Oops, sorry. I use this corner to explain to you. So basically, we have the formula now, right? The formula is that RQ equal to 3 beta T, all right?
Yeah.
And from the condition, you know the condition first. We know the beta. Beta can be solved. Can you see? Beta is equal to, can you see my condition? Equal to R1Q divided by 3T1.
T.
Yeah, that's T. So this 3 canceled, right? So that formula for the R is solved. I just continue right down here. You see? That is R1Q divided by T1. This is constant, multiply T, okay? The second is R2. So the double, okay, what is the final? This
2R1.
2R1. So the second is 2R1 to the power Q, or equal to the T2. Can you see? This is R1 over, this is just R1Q and divided by T1. That's our T2, can you see? So in this way, we can solve the T2. Do you agree?
Yeah.
Okay, it's just some arrangement. Can you see this Q? Oh, RQ canceled. Can you see? R1Q canceled. Oh, we can simplify. Can you see this canceled? Can you see? So what we have here, we got Q2 is 8, right? It's 8. We got 8 and divided by T1. Oh, it should be multiply T1. Oh, yes, that's right. Okay, finally, the time taken, we use this formula, is equal to T2. Take T1, you see?
Oh, so it's like 8 T1.
I don't care the numbers, you see. I just make sure you know the method, okay? It's simple, it's just algebra now, can you see?
Yeah.
So that is 8 T1, yeah, minus 1T, 7T1, can you see?
Yeah. But they still have T1.
Oh, T1 is, you don't worry about, T1 is given.
Oh, okay.
In term of T, when you have read the questions, in term of T, which means you don't worry about T1. Yeah. Interesting question.
Yeah.
That's interesting question. I will save that. And go to next one.
You still have so many pages.
Yes. This binomial. This you have done this before, right? This is just replacement. Do you know this type of question in Math C, in the special needs math?
Yeah, but I forgot the formula.
You forgot the formula. Oh, binomial. Binomial is a basic. Can you write down here?
Something C, something C.
Now, before that, can we recall the formula? It's binomial. Binomial because they use A, B, X already. I would use alpha and beta, okay? I'm trying to avoid using the same notation.
Okay.
Okay, use this one. if you write a binomial formula, that will be the notation. Can you see? That is a C, that N take K, or you can use R, doesn't matter. So it's a K from 0 to N, you see? First is alpha to the power of K. Second is beta to the power of N take K. That is a binomial theory. Can you follow me?
Yeah.
So NK, do you want NK? NK is a combination formula.
NCK.
Yeah. That is a factorial, can you see?
Oh.
N take K.
Oh, how do you remember all of this?
Well, doesn't matter. At a certain stage, I will help you to summarize formula, all right? Where is my example? Don't worry, at a certain stage, I show you how to summarize the formula in one page, all right?
Oh.
Anyway, that is binomial formula. So how can we deal with that? In our case, so in this case, so what is alpha? What is beta? What is alpha and beta?
A and bx.
A and beta is equal to bx, can you see?
Yeah.
What is n? What is n?
N is C.
That's right, okay?
Yeah.
So you just substitute this into this formula. So therefore, we can argue that A plus B, just do substitution. That will help you. In C will equal to, can we use a sigma notation? So this is a K from 0 to N to C, okay? Can change, can you change? It just changes A to the power of K. Beta is Bx, you see, to the power of N, that's C, sorry, C, take K, all right? That's it. So they are looking for a particular term, right? Expand C is a positive integer as a polynomial X up to including term of X2. So you were these we were stopped at just involved X2, right? Up to including 2. So we were basically we are looking for the term which contained X0, okay? And X term count 1, and it's just polynomial X2. So we have worked out all this term, all these three term, right? Can you follow me?
No.
Yeah. So you have to interpret this question. This is I think this is specialist in the math. So basically, you have to interpret this question. So to expand it as a polynomial in X up and including X squared.
This
so
is the
yeah. So can you, without go further, do you think, can we just write down here? So this can be written as this coefficient 1 in C. I can use I use C already. Can we use something else? Can we use coefficient? Just A, okay? A1, can you see? A1, A0, can you see? A3, can you see? A2, A1 plus A2, okay? Of course, this is unfinished. Can you see the whole? If you want to go further, that is never finished. That's A3 to the power of the Q, okay? And it's just go on for large numbers, right? The large number would be AC to the power of the C. Can you see? However, in this case, they only ask you to write the first 3 terms.
Oh, so it means a random expression.
Yeah.
So that means like A plus Bx. C is less than equal to X squared.
No inequality. No, they just as approximation. You see, if you want to use all of them, maybe you have to count if C is large number, right? If C is large number, they didn't tell you C. If C is 10 or 20, right? You have to write 20 plus 1, 21 term, too many. That is that was this sigma mean. So what I do, I show you, I will expand that in order to find this term first. Can you see? First, I will find the x2 term here. Can we put this can we put a b here? How about first k equal to 0? K equal to this is a to 0 is 1, all right?
Yeah.
And this would be a that would be that is a bracket. I use bracket bx c, right? The first is this term, right? The second term x equal to 1. So that is we have considered this coefficient. It's not straightforward. Yeah.
I forgot.
So n there, so n and k. So we have multiply. We have
C.
multiply. Yeah, we got to apply the C0. Okay, C0. And the second coefficient is C1. Can you see?
Let's just see.
You see. So this time we got our alpha term. That is A. Can you see? A multiply B C minus 1 term, right? Bx C minus 1 term, minus 1, right? The third term will be C2. Can you see?
Yeah.
And A squared and multiply Bx C minus 2. Now, so you can continue this, right? They have, as I said, they have many other terms. Can you see? I just wonder, can we stop here now? Because they are looking for the term contain x squared. Now, how can we know we got x squared? We probably have to go to backward. Can you see? This summation could come from the first, from k equal to 0, because it's a summation. We can also find the last 3 term first, can we?
Yeah.
So in that case, if that's the case, we have to find, make sure can insert this space here. Do it again. Oh, it's not straightforward. So because here we don't know C, right? Oh, hang on. Do we have this condition taken? If the coefficient x null term is equal to this number, or they give you this number, b is equal to 1/4, and the coefficient x2 is this one. Find A and C. Wow, that is a challenging question. So this is the first part, right? So this first part is A, can you see? This is B. Do you agree? They contain 2 parts, this question.
No, I think the top one is just description. Second one is the question.
Second one is question.
Yeah.
Well, how do we know the x0 term? Can you see? They basically they say this 3 number is given, right?
What does that mean? What does this one mean?
No, what it means that this expansion can we just return? We just go to this one. Okay, return to this one. This if you expand that, they will go to the this is bx. Okay, the power of c. So if you start from first one, this term other are constant. Can you see these other constants? They got r x to the power c. Can you see? Can we write backward now? You see, the second part would be the x to power of c minus 1. You see, can we call this? This is c minus 1. You see, that is x c minus 1. Do you agree? These a are constant. C minus 1. We don't worry about too much the detail. You see, that's why I think this test is very focused on analytical. Can you see? We can put all constant as a single notation. Did you notice that today I always use a single letter to represent many numbers? All right.
Yeah.
That's how you can simplify mathematical expression. Okay. Now here, can we just continue right here? So that is C minus 1. And this until, can we just found the last 3 term, all right? This first 3 term. The last 3 term, they know that, can we this time we use the B, can you see? We just use different notation. Okay. That is B is X squared term, can you see? X squared term. And that is, that would be minus, that would be minus, how many?
No.
Let's just write it as 3 term here. That's a 3 term. So X to the power 1. And the last is just a constant term, X to the power 0. Can you see?
Yeah.
But how do we? The last one, I can move backwards. So the last one is C minus K, right? This is C minus K. And let's continue next time. All right. Okay. So that's the direction to go. If you have time before Wednesday, you can just focus on these 3. Can you see? I was going to solve this way. Can you see? First, I just counted from the K equal to 0. I got this high order. All right. So I realized that what is after is looking for the last 3 term. Can you see? That is yellow. Can you see? This is the last 3 term. Do you know what I mean?
Are they the first 3 terms?
These are the first. These are first 3.
Oh,
the first
yeah,
3. Can you see?
3. Yeah.
First 3 term. And this term. These are the last. Can you see? They're after the last 3 term.
Yeah, I think I know how to do it.
Yes, I think we're. Yeah, it's just a little bit. You have to be patient a little bit.
Yeah. Okay.
Okay, let's stop here. Save that.
Thank you.
Okay. See you next time.
See you.
Goodbye.
Bye.
Bye.